Alright, so day 6, we are looking at solving absolute value equations and inequalities graphically as well. Besides algebraically, we're looking at graphs today. Okay, so algebraically, I have 4 is equal to 1/3 x minus 2 is in absolute value. I want you to see these up here. I don't think you have these in front of you. You're more than welcome to write them in your notes as well, like on regular notebook sheets of paper. I'm going to subtract the 3 because my goal algebraically is to isolate that absolute value. Okay, from here, I would get rid of the 1/3 by multiplying both sides by 3, and I would get to something that looks like this. Okay, so guys, when you isolate the absolute value, we just had a question just now at team 3. Okay, so Corbin and Nate were talking about how do you know from here if it's going to be an answer, all real numbers, or no solution. Okay, these are those quote-unquote trick questions that you have to ask yourself at this point in time. Guys, can the absolute value of something be a positive 3? Yes or no? Yeah, so you know that there's possible answers. Had this said a negative 3 at this step, what would be the answer? No solutions. Because you can never take the absolute value of something which will become positive and equals some negative number. Okay, so always when you isolate, think about that question then. Okay, so now that I know this is okay right now because I can get a positive 3, I'm going to go ahead and break it up algebraically. And this is what we were doing last couple of classes. What's an absolute value? We write them without absolute values. And then what we see and the negative of what we see. So solving this out algebraically, if I keep going, I want to say that getting x by itself will have 5, getting x by itself will have -1, and if I put it on a number line, I'm looking at -1 and +5 just as single points because it's not an inequality. No conjunction, no disjunction, just 2 points that stand all alone. And we've done a lot of practice with this. From this, in practice, we checked our answers. -1 minus 2, you help me out, is what? -3, right? Absolute value of -3 is 3. 3 times 1/3 is 1. So -1 checked out. Doing a little bit reviewish. 5 minus 2 is 3. Absolute value of that is 3 times 1/3 is 1. This one works. So algebraically, I got 2 answers from this. Okay. Graphically, it's a little bit different. Okay. So graphically, you can do it like this. On the left side, I have y equals 4, which is just a horizontal line at y is equal to 4. On the right side, I have a totally different function. It's the absolute value. So from the absolute value, it's been shifted 2 to the right, it's been compressed, and it's been shifted 3 up. Okay? So imagine 2 to the right, vertically compressed, so it has a slope of up 1 over 3, up 1 over 3, and then it's shifted also 3 up. So here we go, 2 to the right, 3 up, and it has up 1 over 3, up 1 over 3. This one has up 1 to the left 3, up 1 to the left 3. And my answers of where they will exist, this is a little bit off scale. Let me draw it a little bit better so it doesn't confuse you. Will be at the intersections of those 2 graphs, which in this case are going to be at +5 and a -1. Right here at -1 and right here at +5 is when those will intersect. Questions? That's when those 2 graphs are equal to one another. Okay? questions? All right, so let's go to our next example. So our next example is 1/3 minus 2 algebraically. Oh, and I know what this one was. I should have done a half sheet on this. No worries, we'll save paper. Let's do this example right here. Name 3 x values that are solutions. Name 3 x values that are not solutions. I didn't have this in the first one. Why do I have that in this one? Why are they asking me this here, but they didn't ask me that on the other example that we just did? Because it's an inequality. Okay? So I'm going to have shaded regions. Okay? So let's go ahead and 2 is right here. Y is equal to 2. And all of this is my other equation. Okay? So this one, from a normal absolute value, is going to be, Anna, what's this transformation? Perfect. Horizontal stretch by 4. So looking at this, it's going to stretch by 4. So it's going to look something like that, to where instead of up 1 over 1, up 1 over 1, it's now going to go all the way 4 up 1. All the way 4 up 1. You with me? Because it was stretched horizontally by 4 up 1. And then it was shifted 1 unit up. You with me? So if I graph this, here we go. Shifted 1 unit up. The vertex now is going to be here. And this was that stretch of 4. So 4 and then up 1. 1, 2, 3, 4, and then up 1. Looks like this. And then the other way. 1, 2, 3, 4, up 1. Looks like that. Our answers look like they're intersected here, but the thing is, it's not just an equal to. This is an inequality. Okay? So let's go ahead and figure this out algebraically so we can wrap our heads around what the answer is going to look like and how it makes sense graphically. What would I do algebraically? Subtract 1. Nice. 1/4 x is less than or equal to 1. And here's where I ask my question. Is this possible? Can I get a positive answer and it be less than a positive? You know what I mean? Or equal to a positive? Yes. Okay? So I know it's not going to be a weird no solution or all real numbers per se. Okay? So what do I do here? Corbin, what would I do here?
You would do the 2 equations.
2 equations. Perfect. And the 2 equations, Joel, what are my 2 equations?
1/4 x is
Keep going. 1/4
less than
x.
or equal to 1, and then the other one would be 1/4 x is greater than or equal to -1.
Awesome. Nice. So you set it up, you do the negative flip. Oh, and from here, let's solve the first one. What do I do?
You just multiply 4.
Okay, and I get just that, right? Okay, oh, and what would I get for the next one? Read out the answer to me.
X is greater than or equal to
Yep. Anyone, why didn't I just flip this just now? Because I was not dividing nor multiplying by a negative number. Okay? So as this is a number line, Sarah, what am I going to do? Is it going to be a disjunction or a conjunction? Okay, so why do you say that? Where do I shade? Tell me where to go.
You'll go from 4 all the way to the left until you get -4 and -4 to the right until you hit 4.
Perfect. So these arrows are nice little scratch work. She said go to 4 and shade to the left because everything that's less than, and that's why I put an arrow to the left. Go to a -4 and shade everything to the right because we want x's that are greater than -4. So if I do this, what's the word that you learned today that you need to write down in your answer? And. So this is a conjunction where it's and. That means this and that. And I like the way Pearson has you guys doing this a lot, because the way they want you to write this is -4 is less than or equal to x, which is less than or equal to 4. A conjunction with and, you can write, it looks like 3 terms from low to high. Okay? A disjunction you can't write like this. A disjunction, you need 2 inequalities that are separate, because those are going to be or. Disjunction is or, conjunction is and. Any questions? Okay. So if this is my answer, it's saying that between -4 and 4 are my answers. That means my answer should be right here, in this kind of shaded region, if you will. It's saying that the red graph is below or equal to the line of 2. Does that make sense? So let me shade it a little bit better, because that might be a little bit confusing. It's saying the red graph is less than or equal to, that means below or equal to, the other graph. So if I go to shade it, this is where it's below the blue graph, or equal to. And the answers of where that occurs is between -4 and 4. You with me? Because past 4, the red is no longer below. It's above. And we want where it says less than or equal to that line. Does that make sense? Okay. Alright, so now let's go to the paper that you have in front of you. And these look like... Oh, and on that real quick that we were just on, just to finish it off, when it said name 3 x values that are solutions, you could say what? 1, 2, 3. Go with me? Michael, what's an x value that's not a solution? -5, yep. Because at -5, the red graph is not greater than, or it's not below the blue graph. Okay? Skylar, what's another one that is that are not solutions? +5, yep. And then one more. Santiago, what would you say that is not a solution?
+7.
+7, cool. Because it doesn't make the original statement true. Okay. So now let's go back. Let's start on this new one. And we're going to look at solving, again, algebraically and graphically, these kind of examples. But now you have those to follow with me. Okay? Yes? Oh, no question. Okay, so let's go algebraically. Tyson, hook me up algebraically. How do I solve this absolute value? What would I do? Multiply both sides by 2, because you're trying to get rid of this 1/2, right? Okay. So 4 is equal to x plus 1. Keep going, Tyson. What do I do next?
Subtract 1.
Not subtract.
Absolute value of x plus 1 is equal to -4. And the same thing with +4.
So these things, right? So tell me what's right for the first one.
Absolute value of x plus 1 is equal to 4.
Okay, so some people get this mixed up by still putting an absolute value. You don't need it anymore. Okay, so once you do these 2 breakdown equations, these go away. Okay, so they're gone. So all I would write is x plus 1 is equal to 4, and the other one, Tyson?
X plus 1 is equal to 4.
Perfect. Brianna, from here, what should I do? Both of them. yeah, let's do the left one first.
You subtract the 1.
Perfect, and you get this one, and then
You subtract the 1 and then you get -5.
perfect. Brianna, is this a conjunction or a disjunction? Or neither? Perfect. It's neither because it's 2 points. It's not an inequality. Okay? So yes, if I had it on a number line, we'd have -5, we'd have 3, and yes, they would just be 2 points all by themselves. Alright, so let's check together. Let's check 3. The absolute value, or 3 plus 1 is 4. The absolute value is 4, so that one checked out. Okay? That was 3. Now if I put in -5, anyone, the -5 plus 1 is what? -4. The absolute value of that is 4. And that one checks out as well. Now let's go for the graph. So this is very similar to what we just did. I'm going to do the left side of the equal sign. All of this left side is in blue. Okay? So y is equal to 2. And all of this right side, let's go in orange. Okay? Let's see. Jordan, how do I graph what I have circled in or boxed in orange? How do I do that? Perfect. Move to the left 1 and then what? Vertical compression by 1/2. Okay? So if I do vertical compression by 1/2, anyone in the class, what's the slope? 1/2 or a -1/2, right? So let's move to the left. There's my vertex. And then I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. And then I'm going to go up 1 to the left, 2. Up 1 to the left, 2. And it'll look something like this. So my answers should be from the graph at 3 and at -5, and that's what I got algebraically. Raise your hand, be honest if you think this is easy right now. Okay. Okay. So far so good. I think the inequalities are a little bit more to look at. Let's go. Alright, Morgan, I have -1 is equal to -2 times the absolute value of x minus 1. Morgan, set us up algebraically. What do we do first?
First, you divide by -2.
Perfect. So if I divide both sides by -2, I will get that. Okay, Morgan, what's next?
Next, you get rid of the absolute value and bring it to your equations.
And what are the two equations?
-1/2 is equal to x minus 1 and 1/2 is equal to x minus 1.
Perfect. So we have x minus 1s for both of them, and one is equal to what you see, and the other one's equal to the negative of what you see. Okay? And then, anyone, when I add 1, what's that the same as adding since it's a fraction? 2 over 2. So I'm adding 1 is the same as adding 2 over 2. Adding 1 is the same as adding 2 over 2. Because we need common denominators. So what's -1/2 plus 2 over 2, anyone? 1/2. And what would I get, oops, what would I get on the right side? 3 over 2. So these should be my answers. 1/2 minus 1 is -1/2. The absolute value is 1/2. That one checks out. 3/2 minus 1, which is the same as 3/2 minus 2 over 2. This is 1/2. Yes, that one checks out as well. So here we go again. -1 is my y equals horizontal line. This one over here, let's look at transformations real quick. Okay, just make sure that we have a handle on transformations. Grant, what do I graph here with negative 2 times x minus 1?
Well, it would be a vertical stretch.
It's a vertical stretch, yes.
Reflection
Reflection over
of the x-axis.
the x.
And then it would be 1 unit to
1 unit to
the right.
the right. Just remember the order though, okay? Especially when you're drawing this by hand. It needs to be B, which there's no B here, but the C would come first. Grant, which one of these is the C?
The negative 1
Yep, so I'm going to shift 1 to the what? You said it.
to the right.
Guys, when we first did day 1, I know this was a little bit confusing. Let's see if you remember. If I asked you, what does C equal in this equation? What do you say? 1 or negative 1? You say 1. You say 1 because C is the opposite of what you see. Because it's with x. Okay? And then A, there's kind of 2 values of A right now. You see them? The negative is one of the A, and then the 2 is the A. So you shift it 1 to the right, reflect it, and then stretch it. So from this vertex point, it's going to look down. How much do we go down and to the right and stuff like that? Thomas, what do we do?
Okay, so, well, the points for the y-intercept is -2.
So negative 2. So it's down 2 over 1. Down 2 over 1. And then, because it's a steepness of 2. That's why. Okay? And then the other one is down 2 over 1. Down 2 over 1. And that one is a steepness of 2. And yes, sure enough, 1/2 is right here. And then 3/2 is right there. So 1/2 and 3/2. Okay, so I think that's, and you guys, a lot of you did raise your hand. I think that's fairly easy. Let's move on to this next one.